Slope and lines, slope and lines. Here's a video about slope and lines. Hey, very quickly, you should be reading section 2.2. I'm not going to do a video on 2.1, but what I'm going to do is spend about 10 minutes discussing very basic, very fundamental concepts of linear equations and lines from algebra. So, when you start thinking about the first introductory class, which you're in, Math 171, Algebra, you really start thinking about certain concepts like solving equations, graphing functions, dealing with lines and slopes, logarithmic exponential functions, finding zeros of polynomial functions using synthetic division and factoring techniques. So all these concepts are really, really important. And, when you start thinking about things like the pitch of a roof, the grade of a road, the slope of a line, they're all talking about the same thing. That little letter M, that stands for slope. So slope, I'm going to discuss that for a few minutes. There's only 4 types of things a line's going to do. It's either going to be increasing, it might be decreasing, let's see, left or right, increasing, decreasing, horizontal, or vertical. So let's look at 4 examples real quick using the formula. So as you can see, the way that I like to say it is change in y's, which is rise. So it sounds almost the same. Rise and y's. Rise and y's. So that's in the numerator, and the change in x's over the denominator. Very important. I mean, if you're going to build a wheelchair accessibility ramp, to a building, you can't make it whatever slope you want. I mean, if you make it too steep, you'll never get the wheelchair up there, and then if you do, you're gone. So there's a certain rise to a certain run that you really need to have. And so let's look at these ordered pairs. So what I do is this. I say you're an x, you're a y, you're an x, you're a y, you're the first point, you're the second. So that's where these subscripts, y sub 2, that just means the y value of the second ordered pair. Now keep in mind, it doesn't matter if I go, you're an x, you're a y, you're an x, you're a y, you're the first point, you're the second. It doesn't matter which ordered pair you let be first or which ordered pair you let be second, as long as you're consistent in your subscripts. In other words, we can't have this being a 2 and this being a 1. That doesn't make any sense. The subscripts just say which ordered pair we're dealing with. So let's use the formula real quickly. What I always do is do that. So change means subtraction. So -4 minus -2, and then 0 minus 3. So let's see what happens. Some of you like that keep, change, minus a -2. So it's -4 plus 2, which is -2 over -3, which is a positive 2/3, a positive slope. So what that means is, if I were to graph 3, -2, and then graph 0, -4, we quickly see that this is a line that rises to the right, hence the positive slope. Very cool. Well, let's do this one. So so let me set up, there we go. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And what we get here is 1 minus 0 is 1, -5 minus 3, that's -8. Holy schmoly, a negative slope. So let's see what happens when I plot these. -5, 1 is right there, and then 3, 0. Did I do that right? -5, 1, and then 3, 0. So holy cow, look at this bad boy. This bad boy is dropping from left to right, and notice that it's a very subtle drop. But if we look at it closely, we can almost see something really cool here. It goes down 1, and then it goes over 8. Like this one right here. This one goes up 4. Let's see, make sure that's right. 1, 2, 3, 4. And then over, I didn't quite say how many that went over, so it's a little trickier to see because I stopped putting my little tiki marks. But we would have seen probably over 6, so up 4 over 6, which reduces down to 2/3. So that's pretty cool. You can tell the slope of a line by looking at it visually or using the formula. Now let's move on to this next one. So this is m equals x, y, x, y. You're the first point, you're the second. 3 minus 1, and then 4 minus 4. Uh-oh, this is 2 over 0. Dividing by 0, oh, we'll talk about that in Calc 1 quite a bit. But dividing by 0, oh, this is undefined. Undefined. So what happens here is, if I were to graph 4, 1, so over 4, up 1, and I were to graph 4, 3, over 4, up 3, we notice that those 2 points give us the graph of a vertical line. Vertical line. A vertical line straight up and down, undefined slope. In other words, it has all the rise in the world, it doesn't have any run. So finally, let's look at this ordered pair. X, y, first point, second point. So this is 4 minus 4 over 5 minus a negative 2, and it does not matter as long as my denominator is not 0. 5 minus a negative 2 is 7, 4 minus 4 is 0. I have 0 pieces of candy to divide amongst 7 children. How many does each child get? They get 0, because I didn't have any. So this is a slope of 0. So when I graph this bad boy, this is negative 2 up 4. This is 5, 4, 1, 2, 3, 4, 5, and up 4. We have the graph of a horizontal line. It has no rise, but it has all the run in the world. It's a horizontal line. Pretty much what you want your soccer fields, basketball courts, baseball fields. You know, you want those to be pretty level. So these are 4 different cases, and the only 4 cases you can get with the slopes. So it can be positive, rising to the right. It can be negative, falling to the right. It can be undefined, which is vertical, or it can be horizontal. And this slope formula is awesome. But over here, what I've got is different forms of the actual equation of a line. And you know what? I remember in college I wrote a paper about the 16 ways to look at a line. Pretty sure my instructor didn't read it. It was pretty boring. But you know, a line can be a barrier. A line can be a border. A line can be a recipe for finding other points on that line. So when I look at y minus y sub 1 equals m times x minus x sub 1, it almost looks like this slope formula where I multiply both sides by the denominator. So if I do that, I get this y's being subtracted equals m. So this is pretty much the slope formula. It's your template, for writing the equation of a line. If you need to write the equation of a line, I would automatically start off just writing that formula. There's other techniques that you can find online and in your textbook. But right here, if I were to say, hey, I've got the ordered pair 2, 4, and the slope of 1/2. All I need to do to write the equation of that line is to plug it in. This is y minus y sub 1 is 4 equals the slope 1/2 times x minus 2. And that is the equation of a line in point slope form. This form is great. It's your template. So if you memorize that, and it's pretty easy to memorize once you know what the slope formula is, you got it right there. Now, I know a lot of times, teachers will say solve it for y, because the problem is there's an infinite number of points on any line. So the same line can have an infinite number of point slope forms depending on which point you choose. The slope's always going to be the same, but the point could be different. But once you solve it for y, you put it in what's called slope-intercept form. So if I take the time to solve this one for y, I get 1/2 x, 1/2 times negative 2 is negative 1, and then I add 4 on both sides. So once I add 4 on both sides, I get y equals 1/2 x plus 3. This is y equals mx plus 3. This is our slope-intercept form. It is very, very easy to graph. In other words, if I let x equal 0, what's left is 3, my y-intercept. So this is 1, 2, 3, put the point there, and then the slope is 1/2. That means that the line is going to go up 1 over 2, up 1 over 2. You connect those dots, la 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 la, you've got the equation of the line. And lastly, we have what's called standard, which is very similar to what some textbooks call the general form. This ax plus by equals c, it is easy to find the intercepts when it's in this form. So if I just pick a random line, 3x minus 2y equals 6, that line is written in standard form. What I can do is let y equal 0, and now I see that 3x equals 6, x equals 2. The ordered pair 2, 0 is on that graph. If I let x equal 0, I notice that to solve this, I've got y equaling -3. So I've instantly found both the x and y intercepts using standard form, which means it's actually easy to graph too. I could take this bad boy and solve it for y and put it back in slope-intercept form, so all these forms are interchangeable. Last but not least, and I'm running out of time, but there are two other linear equation forms that some instructors really like to harp on, and one is like y equals a number. If I have y equals 2, this is the graph of a horizontal line. So if we look at this horizontal line right here, we see that the equation of it would simply be y equals 4. Now, we could use our template that we want to and plug in 0. You'll get this with this equation. Over here, this is another one. If we have x equals a number, like in this case, like x equals -4, that's the equation of a vertical line. Like in this case, x equals +4 is our equation for this vertical line. Notice that the vertical line does not contain the y value. The horizontal line does not contain the x value. So watch this video a few times, read section 2.2, look at the other videos on linear equations and slope and how these different forms interact. We'll see you next time. Graphing lines. We graphed a couple lines and we did okay.